Hello? Oh, I thought the mic wasn't working. I realized that there's an issue and it's gone. Voila. Thank you. I thought today I will put my ear, what are these? Headphones, not earphones, down for a hat. Hello, sorry for keeping you waiting. I said 15 minutes. I think it's been 20. Good morning, good night, good evening, good. I'm live, right? I see the loading screen. Checking on my phone. Yes, says excellent connection. I should be live. All right. Thanks for being here, and we are here to study. So let's try and do that. So. Wait, who says that? There's a thing that says so, but I forgot. We lost you for a bit. You're good. We're pretty good. We're green, and now I'm yellow, and now I'm red, and now I'm yellow. Anyway, I'm trying to monitor the thing that's here. So yay, studying. That's what we're here to do. Learning, studying, and mini recap as per usual. Today we are studying, actually finishing, I think almost 20-ish minutes is left from lesson 4 of Introduction to Machine Learning for Coders by Fast.ai, which is taught by the lovely Jeremy Howard. And we're having fun doing that. Yes, there are a bunch of lessons. We are, inshallah, will be 1/3 of the way. No way. I doubt the rest of the lessons will be easy. So for now, even I wouldn't say it's been easy. It's been like understandable. You can understand it because not only does the instructor help, but also the fact that it's like classroom setting, and also the fact that the lovely viewers of the stream always help me understand when I don't, so that's pretty nice. Should I refresh just in case, because I know sometimes it refreshes itself for no particular reason, because like I closed it yesterday and now it's today, it's not yesterday. Quality be good. So let's see where we are. What was that?
Isla?
For like this bulk.
Shoot. Well, great. For some reason, my laptop isn't recognizing my headphone, which is not on my head, obviously. It's... Alright, let's try again.
Bulldozers made in 2010 probably are not close to the type of bulldozers that were made in 1960.
Right.
And if you're taking something that would be very different, like a 2010 bulldozer, and then trying to just drop it to say, oh, if it was made in 1960, that may cause poor prediction at a point because it's so far outside of any training.
So. Absolutely. So, I think that's a good point. It's, it's a limitation of a random forest is if you've got a kind of data point that's like of a kind, which is kind of like in a part of the space that it's not seen before. Like maybe people didn't put air conditioning really in bulldozers in 1960, and you're saying how much would this bulldozer with air conditioning have gone for in 1960? You don't really have any information to know that. So,
air conditioning in 60s. True, we wouldn't know. Yeah, so I mean, I'm sure you remember, but I will give you another mini recap of this. We updated the year column for each year of our sample of I think 5,000, and we then told our model to predict what the price would have been. And the guy is saying, but we don't really know, which is true. Prediction is like, it's weird to predict the past, right? Because like we normally predict the future.
This is still the best technique I know of, but it's not perfect. And you kind of hope that the trees are still going to find some
Meaning.
Useful truth, even though it hasn't seen that combination of features before. But yeah, it's something to be aware of. So you can also do the same thing in a PDP interaction plot. And a PDP interaction plot, which is really what I'm trying to get to here, is like how does sale elapsed and year made together impact price. And so if I do a PDP interaction plot, it shows me sale elapsed versus price.
What is that? So pretty.
Shows me year made versus price, and it shows me the combination versus price. Remember, this is always log of price. That's why these prices look weird, right? And so you can see that the combination of sale elapsed and year made is, as you would expect, later dates, so more elapsed time, is giving me, it's the other way around, isn't it? So the highest prices.
Yeah, it looks like sale elapsed. So let me give you the explanation, because like this is how I get it, and then when he explains it, I'll be like, yes, I got it. The sooner bought, the pricier, because it's elapsed. So buying old things means it's less pricey. Let's see if I'm right.
Are those where there's the least elapsed and the most recent year made.
Yay.
So you can see here there's the univariate relationship between sale elapsed and price.
What's a univariate relationship? Is that what he said?
And here is the univariate relationship between year made and price.
We're looking at a relationship between columns, and we're finding them.
And then here is the combination of the two. It's enough to see like clearly that these two things are driving price together. You can also see these are not like simple diagonal lines, so it's kind of some interesting interaction going on. And so based on looking at these plots, it's enough to make me think, oh, we should maybe put in some kind of interaction term and see what happens. So let's come back to that in a moment, but let's just look at a couple more. Remember in this case, I did one hot encoding way back at the top here. I said max ncat equals 7. So I've got like...
I just realized that I haven't ran the lesson 2 codes for a really long while. So let's tell it to run up to where we last ran. And then we can later, after the lesson is done, we can go over the notebook.
Enclosure erupts with AC. So if you've got one hot encoded variables, you can pass an array of them to plot PDP, and it'll treat them as a category, right? And so in this case, I'm going to create a PDP plot of these three categories. I'm going to call it enclosure. And I can see here that enclosure EROPS with AC on average are more expensive than enclosure EROPS and enclosure OROPS. It actually looks
These two look pretty similar.
like enclosure OROPS and enclosure EROPS are pretty similar, whereas EROPS with AC is higher. So this is, at this point, I'd probably be inclined to hop into Google and like type EROPS and OROPS and find out what the hell these things are. And here we go. So it turns out that EROPS is enclosed rollover protective structure. And so it turns out that if your bulldozer is fully enclosed, then optionally...
Really? Like letting rain and wind come in?
You can also get air conditioning. So it turns out that actually this thing is telling us whether it's got air conditioning. If it's an open structure, then obviously you don't have air conditioning at all. So
fair. I would also do the same.
That's what these three levels are. And so we've now learnt, all other things being equal, the same bulldozer sold at the same time, built at the same time, sold to the same person, is going to be quite a bit more expensive if it has air conditioning than if it doesn't. Okay, so again, we're kind of getting this nice interpretation ability. And now that I've spent some time with this data set, I've certainly noticed that this, knowing this is the most important thing, you do notice that there's a lot more air-conditioned bulldozers nowadays than there used to be, and so there's definitely an interaction between kind of date and that. So based on that earlier interaction analysis, I've tried, first of all, setting everything before 1950 to 1950, because it seems to be some kind of missing value. I've then set age.
The thousands. We have year where it used to be thousand. Did I get an issue with this? Is there an issue with the stream? Because it stopped for me for some reason on mobile, which is what I'm using to monitor. I think that YouTube is telling me that the connection is excellent, but I don't know how bad the lag is for you guys. So lag, or even just dropped frame, image not working great, stuff like that. So do let me know if there's an issue in like maybe a bit. I could try do a BRB and fix it, but if you guys think it's okay, then I will just let it be.
Age to be equal to sale year minus year made. And so then I try running a random forest on that, and indeed
we have that's cool, creating age. I thought sale elapsed gave maybe not the same information, but like pretty similar information. But it doesn't.
Age is now the single biggest thing. Sale elapsed is way back down here. Year made is back down here. So we've kind of used this to find an interaction. But remember, of course, a random forest can create an interaction through having multiple split points. So we shouldn't assume that this is actually going to be a better result. And in practice, I actually found when I looked at my score and my RMSE, adding age was actually a little worse. We'll see about that later, probably in the next lesson. Okay. So one last thing is tree interpreter. This is also in the category of things that most...
No. What, you see it as if it's over? What? See, I know there was a cut, that's why I'm asking how bad is it. Oh, I'm sorry. I guess you might have not heard me asking. Don't know if it's an internet error or if it's from my side. I know, like, YouTube is telling me. YouTube is telling me I have excellent connection, and then the stream cut off from my phone where I'm monitoring it. So I was like, is it good or is it not good? So even now, is the image bad? Is like, if it's bad, I will try to fix it, but for the cuts I can't really do much about it. But at least if if resolution, or if the image, the voice, something is bad, I will try to fix that part. Yeah, I think the main issue is the cuts, which happens, I don't know why, it just cuts off, and you're like, wait, it ended, and then you refresh and it's still there. It's pretty annoying. What can I do? Tiny YouTuber, if I can call myself that. Yeah, patience is what we can do. Because it's probably the issues on my side, I don't know. Okay. Did you see he added the column age of the thing, like the car truck thing? I thought sale elapsed. I actually mean patience on my side, but thank you, patience. I don't expect patience on your side. You can go watch someone else, I don't mind. But thank you, I appreciate that. See, you've been gone for like a minute. That's so annoying, YouTube. Anyway, yeah, he added the age column after looking at cell elapse and things like that, and he saw that it's actually pretty important. I think that's what this is. I think this is feature importance we're looking at. Let me double check. Yeah, feature importance.
And so then I try running a random forest on that, and indeed, age is now the single biggest thing. Sale elapsed is way back down here. Year made is back down here. So we've kind of used this to find an interaction. But remember, of course, a random forest can create an interaction through having multiple split points. So we shouldn't assume that this is actually going to be a better result. And in practice, I actually found when I looked at my score and my RMSE, adding age was actually a little worse. We'll see about that later, probably in the next lesson.
Really? Quite interesting.
Okay. So one last thing is tree interpreter. This is also in the category of things that most people don't know exist, but it's super important. Almost pointless for like Kaggle competitions, but super important for real life. And here's the
And research? Okay.
idea. Let's say you're an insurance company, and somebody rings up and you give them a quote, and they say, oh, that's $500 more than last year. Why? Okay, so in general, you've made
Why not? Don't ever say why to money. Okay, maybe do. It has to be at least be halal, you know?
a prediction from some model, and somebody asks why. And so this is where we use this method called tree interpreter. And what tree interpreter does is it allows us to take a particular row. So in this case, we're going to pick row number 0, right? So here is row 0, right? Presumably this is like a year made. I don't know what all the codes stand for, but like here's all of the columns in row 0. What I can do with a tree interpreter is I can go ti.predict, pass in my random forest, pass
model.
in my row. So this is
First row. Wait, are we doing interpretation per row? Let's see.
be like this particular customer's insurance information, or this, in this case, this particular auction, right? And it'll give me back three things. The first is the prediction from the random forest. The second is the bias. The bias is basically the average sale price across the whole original data set, right? So like, remember in our random forest, we started with single trees.
Yes.
Oh, we haven't got a draw in there anymore. But remember, we started with a single tree in our random forest. And we split it once, and then we split that once, and then we split that once, right? And we said like, oh, what's the average value for the whole data set? And what's the average value for those where the first split was true? And then what's the average value where the next split was also true?
I remember the picture.
Until eventually you get down to the leaf nodes where you've got the average value you predict, right? So you can kind of think of it this way. If this, for a single tree, if this is our final leaf node, right, maybe we're predicting like 9.1, right? And then maybe the average log sale price for the whole lot is like 10.2, right? That's the average for all the auctions. And so you could kind of like work your way down here. So in fact, let's go and create this. Let's actually go and run this so we can see it. Okay, so let's go back and redraw this single tree. You'll find like in Jupyter Notebooks, often a lot of the things we create, like videos, progress bars and stuff, they don't know how to like save themselves to the file. So you'll see just like a little string here. And so you actually have to rerun it.
They don't know how to save themselves. That's just a weird sentence, isn't it?
To create the string. So this was the single tree that we created. So the whole data set had an average log sale price of 10.2. The data set for those with coupler system equals true had an average of 10.3. The data set for coupler system equals true, enclosure less than 2 was 9.9. And then eventually we get all the way up here, and also model ID less than 45.
Without context, it's going to be weirder. Save themselves from what? My brain just went to, kids. Kids don't know how to save themselves. So basically, Jupyter Notebooks are maybe kids? Nah, they're too good. Kids are not good. Kids are useless. But in a nice way.
573, it's 10.2. So you could kind of like say, okay, why did this particular row, let's say we had a row that ended up over in this leaf node, why did we predict 10.2? Well, it's because we started with 10.19, and then because the coupler system was less than 0.5, so it was actually false, we added about 0.2 to that, so we went from 10.1 to 10.3, right? So 10.2 to 10.3. So we added a little bit because this one is true, and then to go from 10.3 to 9.9, so because enclosure is less than 2, we subtracted about 0.4, and then because model ID was less than 4500, we added about 0.7, right? So you could see, like with a single tree, you could like break down like why is it that we predicted 10.2, right? And it's like at each one of these decision points we're adding or subtracting a little bit from the value. So what we could then do is we could do that for all the trees, and then we could take the average. So every time we see enclosure, did we increase or decrease the value and how much by? Every time we see model ID, did we increase or decrease the value and how much by? And so we could take the average of all of those, and that's what ends up in this thing called contributions. So here is all of our predictors, and here is the value of each. And so this is telling us, and I've sorted them here, that the fact that this thing was made in 1999 was the thing that most negatively impacted our prediction. And the fact that the age of the vehicle was 11 years was what most positively impacted.
I don't
I
know.
think you actually need to sort after you zip them together.
They seem to be sorted, negative 0.5,
Well,
negative
no, the
0.1.
values are sorted, but then they're just reassigned to the columns in the original order. Which is why an 11-year-old tractor is what's most
Thank
positively
you.
impacting price.
What?
Thank you. That makes perfect sense. Yes, we need to do an index sort. Okay. Thank you. We'll make sure we fix that by next week. So,
That was cool. Is it someone called Ter or something? He's really smart.
we need to sort columns by the index contributions.
1 minute left. I'm gonna check my code and see if it's fixed.
So then there's this thing called bias, and so the bias is just the average before we start doing any splits, right? So if you basically start with the average log of value, and then we went down each tree, and each time we saw year made, we had some impact, coupler system, some impact, product size, some impact, and so forth, right? Never mind. Okay, so I think what we might do is we might come back to, because we're kind of out of time, we might come back to tree interpreter next time.
Really?
But the basic idea, this was the last of our key interpretation points, and the basic idea is that we want some ability to not only tell us about the model as a whole and how it works on average, but to look at how the model makes predictions for an individual row. And that's what we're doing here. Okay, great. Thanks, everybody. See you on Thursday.
Same. See you on Thursday, Jeremy. That was lesson 4. And I am going to... Did we run this? Have you been ran? Yes. No. Okay. So I am looking at the dropped frame rate, and it is getting worse by the second, and I would like to apologize for that. By apologizing, should I do this notebook lesson 2 up until tree interpreter as Jeremy did, and then try to fix, oh my god, it's getting to 40%. That's horrible. I don't know how bad that is though. YouTube is still telling me I have excellent connection. Tell me how bad it is, okay? If it's not so bad, if it's pretty bad, I will try and fix it. Do a 5-minute BRB. So either I do that now or I do it when it gets even worse. I don't know which one is better. Crispy cluster hierarchy. What are we doing? Removing redundant features. I think. Okay. Then I'll go and fix it when it gets to 50%. And now it's 41%, so it's going up pretty fast. So we are... Oh, I remember this one. One thing that makes this harder to enter. Hello! Let me see if I remember the pronunciation of your name. It was Orgo Deep, right? Was that... Am I right? Welcome, what's up? We are... so technically we finished lesson 4, but we're still in notebook lesson 2. Because that's how the lessons are on YouTube. Thank you. So yeah, thank you. Yeah, like these two, these redundant, and here as well. They give the same information. That's how correlated they are. I think this is... No! What happened? Wait a minute. Oh my god, no way! Can you hear me? YouTube is saying that there is no data, but chat was not working.